There are different kinds of changes. A physical change only changes the state or the appearance. It does not change the actual composition. If you look at the atoms or molecules that are making up that matter, they are the same when it undergoes a physical change. Example here is boiling water. Here's an illustration of water molecules in the liquid state and in the gas state. They look like little Mickey Mouse heads. They're the same. All that's happened is it's gone from a liquid to a gas. They're further separated from each other. There's a change that occurs. Steam is very different than water, but the individual particles are the same. And so this is a physical change. In a chemical change, the actual particles of the substance are changed. So here we have an illustration of a nail rusting. The nail is composed of iron atoms that are arranged in a lattice structure. When the iron rusts, it combines with oxygen, and now we have oxygen that's incorporated into this structure. The particles have changed. It's a chemical change. So we need to be able to identify the difference between a chemical change and a physical change, and it has to do with the individual particles. Are the particles the same? Then it's a physical change. You take a piece of wood and you cut it in half. Are both sides still wood? Yeah, you just made them smaller. Physical change. What if you light a match to the wood and you burn it? Is it still wood? No. The particles have combined with oxygen in the air and turned into water and carbon dioxide, and they've changed. That's a chemical change. Dry ice is fun stuff. There's a lump of dry ice being held on a ring, and dry ice is cool. Well, it's cool because it's really cold, but sometimes I amuse myself. I like dry ice because it does this weird thing called sublimation. It goes directly from a solid state to a gas state. So here in the gas state, the particles are close together. It has a fixed shape and a fixed volume, but then it goes directly into the gas state where the particles are separated and they're free to move and expand. In this illustration, though, we see that the particles themselves are not changed. This is a physical change. Dry ice is dry ice because it doesn't make things wet. Regular ice cools things down too, but it melts into a liquid and gets your sandwich all soaking wet right before it evaporates. Dry ice doesn't do that. Sugar dissolving. You put a teaspoon of sugar in a glass of water, you stir it up, what happens? It looks like the sugar disappears, doesn't it? Oh, I can't see it anymore, it's gone. But the sugar, you can taste it in the water, right? It tastes different. Well, what's really happening to those particles? Here are the sugar particles, and they are a solid in the solid sugar. When we put them into the water, they separate and get surrounded by water, and they make a homogeneous mixture, but the particles themselves have not changed. Those sugar particles are exactly the same as they were before. So is this a chemical change or a physical change? It's a physical change. The particles don't change. Here's propane gas burning. So the propane comes up here, and these are the propane molecules. Their formula is C3H8. When the propane burns, it's converted into carbon dioxide and water. So what kind of a change is this? A chemical change. Because the particles have been changed. A new substance has been formed. So here's kind of a summary. No, sorry. It's not a summary. Now we're going to talk about properties. There's chemical and physical changes. There's also chemical and physical properties. they are related. The physical property is a property or a characteristic that the substance displays without changing its composition. So smell, taste, color, appearance, melting point, boiling point, density, the mass, those sorts of things. How long is it? Things that you can observe without changing the particles. Those are physical properties. Chemical properties, when you display a chemical property, you destroy the original substance. You change the composition. So when you demonstrate a chemical property, it involves a chemical change, which we also call a chemical reaction. So basically, chemical properties are just all the possible reactions that a substance could undergo. So we say that gasoline is flammable. Gasoline burns if you set a match to it. Well, when we demonstrate that, the gasoline is changed, and so that's a chemical property. Corrosiveness, acidity, toxicity, these are all examples of chemical properties. That nail that was rusting. Nails rust. Iron rusts. Is that a chemical property or physical property? It's chemical, because when that happens, the particles are changed. So decide which of these is primarily physical and which are primarily chemical. So frost forms as the temperature drops on a humid winter night. Is that a chemical property? Well, is that chemical or physical? It's physical. A cornstalk grows from a seed that is watered and fertilized. That would be chemical. Is when that seed sprouts and combines with carbon dioxide and water, the particles in it are changed and it grows into the cornstalk. A match ignites to form ash in a mixture of gases. Chemical or physical? Chemical. These words are a clue. To form. Ignite suggests burning. Burning is always chemical. But anytime you see to form, that implies that some new substance is being made. It must be chemical. Perspiration evaporates when you relax after jogging. Physical. Evaporates. That's the description of a change, a physical change, from liquid to gas, when something evaporates. So that's a clue. A silver fork tarnishes slowly in the air. Chemical. It's not as common to have silverware. We call it silverware, but usually it's not silver, right? Silverware isn't really that practical because it tarnishes, it reacts with oxygen in the air, and it gets this dull coating on it.